Hi, my dear students. Is it audible to you? So please comment. Is my voice is audible? Sir, రావట్లేదు comments. రావట్లేదు comments. రావట్లేదు comments.
Yes, sir. It's
రావట్లేదు comments. Comment చేయాలి.
వస్తుంది సార్. వస్తుంది.
Yeah, it is audible, sir. Audible. You can call it.
ఇది రాదు comment రాదు. Yeah, yes. Okay. So in this session we are going to discuss the clipper circuits using Zener diode, right? So that means here what is clipper? Clipper is basically a transmission circuit that transmits the signal above the reference voltage or below the reference voltage or between two reference voltages. It means basically it is a non-linear wave shaping network, right? So used to limit the amplitude of the signal to the desired level. If the available input signal is more than the required one to drive the electronic device, then the excess signal, the input signal must be removed. And so whatever the amount of voltage is required can be it allows that much only. And hence you can say clipper is nothing but a amplitude limiter. Clipper is, you can also say it is amplitude limiter. And another thing is, it is also used to remove noise in digital communications. So most of the noise is introduced in the channel, and hence the signal may be distorted. It results distorted output because of channel noise, right? So if the distorted output signal is transmitted through the clipper circuit, it eliminates all the distortions, and so original information can be reconstructed at the output of the clipper circuit. In this way, hence you can certify that the clipper is also used to remove the distortions introduced by the channel in digital communications. So major applications are two. One is amplitude limiter, and the second one is used to remove the noise introduced in the channel during digital communications, right? And so clipper can be designed by using Zener diode. Here Zener diode is very important. So Zener diode acts as voltage regulator. Basically, the basic function of Zener diode is voltage regulator. It is a specially doped diode or special purpose diode, so whose function is to regulate the output or to maintain constant output voltage in spite of changes occurring in input voltage or output load variation, load changes. Right? Even if the input changes, output should remain constant. That is our prime motivation. This can be achieved by using the Zener diode as a voltage regulator. Right? So, and if you observe the VI characteristics of Zener diode, so like this. This is the reverse voltage, VR, and IR in a microamperes. This is practical diode. Once basically it is a reverse bias diode, always operated under breakdown region. Always operated under a breakdown. Once it enters into the breakdown region, then only it acts as voltage regulator. Before breakdown, so it acts as open circuit only. We understood this, right? So that means this is the breakdown voltage, VBD, you can say. So, and this is the characteristics of practical diode, practical Zener diode. And here, once breakdown occurs, the current through Zener diode must increase abruptly, but that is not happening practically. What is happening practically? The current through the Zener diode increases exponentially. This is because of diode resistance. Diode resistance. Diode resistance is inseparably linked with it. To overcome this diode resistance, the voltage must be increased. As a result, exponential increment in current through Zener diode only can be observed practically. Right? So that means, what does it mean? So for practical Zener diode, delta Vz, change in Zener voltage is not equal to 0, and so Rz, the Zener dynamic resistance, is also not equal to 0. On the other hand, so for ideal Zener diode, these are the VI characteristics for ideal Zener diode. This is VR, and this is IR. And once it enters into breakdown region, then the current through the Zener diode increases abruptly. In this case, so the change in Zener voltage is 0, and the Zener dynamic resistance is assumed to be 0. This is ideal Zener diode, and this one is practical Zener diode VI characteristics. Practical Zener diode. So the characteristics of practical Zener diode is delta Vz is not equal to 0, and Rz is not equal to 0. On the other hand, for ideal Zener diode, delta Vz is equal to 0 and Rz is equal to 0. These are very, very important for engineering competitive examinations as well as in interviews also. Right? So what are the physical characteristics of ideal Zener diode? So straightforward answer is the change in Zener voltage is 0, assumed to be 0, and the Zener dynamic resistance is assumed to be 0. Followed. If it is assumed to be 0, then the abrupt increment in current can be practically found through the Zener diode. Have you understood this, right? So, and once it enters into the breakdown region, then it acts as voltage regulator. Voltage regulator means it is able to supply constant voltage. It is capable of supplying constant voltage to be appeared across the output terminals. That means this is due to the fact that the electric field, which that means causes to output to be remain constant. Have you understood this, right? So in the Zener diode before breakdown, if you observe before breakdown, so only I naught current, that means reverse saturation current only will be flowing through the Zener diode, that is due to minority carriers. That means hence you can say that before breakdown, so only two cases must be practically observed as far as Zener diode concerned. So before breakdown, after breakdown. Before breakdown, it acts as open circuit. Right? So after breakdown, it acts as a battery of Vz volts. This breakdown voltage is nothing but Zener voltage. This is nothing but Zener voltage. Followed. If a breakdown occurs at 10 volts, then the Zener voltage is 10 volts. That means the Zener diode is capable of supplying 10 volts, constant voltage of 10 volts to the output terminals in spite of input voltage changes or load resistance varies. Have you understood this? It is able to suppress these variations and able to supply constant voltage to the output terminals. Right? So with this, we can conclude the operation of the Zener diode, which helps us to simplify the problems. Once you understand the concept of Zener diode, then easily you can solve the problems without much difficulty. Right? So the first one is if Vi is less than Vz, that means before breakdown, then Zener diode acts as open circuit. So in this case, the output voltage is same as input voltage. That means what does it mean? So the output follows the input variations, open circuit, shunt regulator. And the second one is if Vi is greater than Vz, then Zener diode acts as a battery of VZ volts. Acts as a battery of VZ volts. That means like this. It can be replaced by VZ volts, constant voltage, battery of VZ volts. That means if VA is less than VZ, so can be replaced by open circuit. And if VA is greater than VZ, then Zener diode can be replaced by a battery of VZ volts. Right? So, and if it is reverse biased, followed because of the input voltage, if the Zener diode is reverse biased, but not in breakdown, that means before breakdown. So then before breakdown means it acts as open circuit. Followed. If it is reverse biased, but undergoes in breakdown, then it acts as a battery of VZ volts. Three cases must be observed. So one is, so when it is forward biased, acts as a normal diode, that means can be replaced by 0.7 volts. V gamma is equal to 0.7 volts. So the second case is, if it is reverse biased, but not in breakdown, right, before breakdown, then so it can be replaced by a open circuit. That means the output voltage is same as input voltage. The output voltage follows the input variations. And the third case is, so if it is in reverse bias but undergoes breakdown, then the Zener diode can be replaced by a battery of VZ volts, constant voltage. Right? So these three things must be carefully observed. So and hence the problems can be easily solved without much difficulty, right? So let us see the problems. So in the circuit shown, Zener diodes are ideal. Ideal in the sense, what does it mean? So the change in Zener voltage is assumed to be 0, and the Zener dynamic resistance is assumed to be 0. And hence, so if it is forward bias, then directly can be replaced by a short circuit. Right? So, and so in this case, the Zener diodes D1 and D2 are assumed to be ideal, and breakdown voltages have breakdown voltages VZ1. This breakdown voltage is 12 volts, and the breakdown voltage of VZ2, that means D2, is 8 volts. Right? If the input voltage is 15 volts peak sinusoidal waveform, then plot the output and transfer characteristics. So first thing is, if the input let VI be positive, the first case is let VI be positive. If VI is during positive half cycle, so what happens? Diode D1 is reverse biased. Why? Because positive is connected to the cathode, and hence diode D1 becomes a reverse bias, can be replaced by open circuits. And D2 is forward biased. That means can be replaced by short circuit. Right? So that means VI is D1 is forward biased, can be replaced by short circuit. D2 is forward biased, can be replaced by short circuit. D1 is reverse biased, can be replaced by open circuit. And in this case, in reverse biased conditions, right? So let us see. So again, two cases. This is reverse biased. No, D1 is reverse biased. No, we have to observe two cases: before breakdown, after breakdown. And diode D1, the breakdown occurs for D1 is at 12 volts. If reverse voltage increases to 12 volts, then it will be entered into the breakdown region. That means the first case is if VI is less than 12 volts. D1 is reverse biased, but not in breakdown. D1 is reverse biased, but cannot undergo breakdown. Cannot undergo breakdown. That means acts as open circuit. Open circuit. That means, what does it mean? So V0 is same as VA. That means the output follows the input variations if VA is less than 12 volts. And the second case is if VI is greater than 12 volts. If VA is greater than 12 volts, then what happens? Now D1 undergoes breakdown. Now it acts as a battery of 12 volts. Now D1 undergoes breakdown. Now it is equivalent to a battery of 12 volts. Can be replaced by a battery of 12 volts, and hence the equivalent circuit corresponding to this is VI and R, and now this can be replaced by a battery of 12 volts, and D2 is replaced by short circuit. Now output voltage is equal to 12 volts, and hence therefore VO is equal to 12 volts. That means, what does it mean? What you have understood from this discussion, right? So till 12 volts during positive half cycle, till 12 volts, if the input reaches 12 volts, so the output follows the input variations. Once it reaches 12 volts level, then it will attain steady state value. That means it is said to be saturated. Even if the input increases beyond that 12 volts, but output is saturated to, that means fixed data remains fixed at 12 volts only. The voltage which is above the reference voltage, that means 12 volts, will be clipped off, will be removed. Have you understood this, right? And the second case is during negative half cycle. During negative half cycle, so during negative half cycle, what happens? D1 is forward biased. D1 is forward biased, acts as short circuit. Can be replaced by short circuit. Why? Because it is ideal diode. RZ is assumed to be 0. And D2 is reverse biased. D2 is a reverse bias. Under reverse biased conditions, just only I told you that. So we have to observe two different cases. One is before breakdown and after breakdown. D2 undergoes breakdown if the reverse voltage increases to -8 volts. Negative half cycle, so reaches -8 volts. That means it is above that. So that means -8 volts. Two cases. The first one is -8 volts is less than, VI is less than 0. Then D2 is acts as open circuits. D2 acts as that means it is reverse biased but not in breakdown. Not in breakdown. And on the other hand, if the negative voltage, that means if VI, second case, if VI becomes greater than -8 volts, then so D2 undergoes breakdown, acts as a battery of -8 volts. -8 volts battery. That means this is -8 volts battery. Have you understood this? That means during negative half cycle, so the voltage, the signal above 8 volts is clipped off. Whereas during positive half cycle, the signal that lies above 12 volts is clipped off. Have you understood this, right? Now I will draw the input-output waveforms corresponding to this. Input-output waveforms. This is omega t, and this is VI. So positive peak of input voltage is 12 volts. That is 15 volts, sorry, 15 volts. That is given in the problem. And during positive half cycle, it will attain, or it is said to be saturated at 12 volts. Right? So for negative half cycle, -8 volts. Right? So the portion above 12 volts is removed, and the portion which lies below 8 volts, -8 volts also can be removed. And finally, the output voltage is, this portion will be applied across the output terminals. Have you understood this? This is output, this is input, and this is the output waveform. Is it clear? And now let us see the transfer characteristics corresponding to this. And this is VI and output voltage VO. And 12 volts maximum. This is 12 volts and minus 8 volts, minus 8 volts. So during positive half cycle, till it reaches 12 volts, the output follows the input variations. After 12 volts, it will at a constant value. Similarly, during negative half cycle, so till minus 8 volt, the output follows the input variations. And once it exceeds minus 8 volts, then it will at a constant value like this, right? So I'll write down here. So this is, in this case, it is V, output voltage is same as input voltage, and here output voltage is 12 volts, fixed at 12 volts, and here output voltage is same as input voltage, and minus 8 volts. Is it clear for you? Right? So this circuit acts as two-level clipper. This circuit acts as a two-level clipper. The clipping voltages are VZ1 and VZ2. The clipping voltages are VZ1 and VZ2. That means the signal that lies above VZ1 is clipped off, as well as the signal that lies below VZ2 also clipped off. Is it clear for you? Right? So if you have any doubt, please comment. Please comment. Are you able to follow my lecture? Please comment. Silent comments. comments. Across the what if the diodes are practical? If the diodes are practical means then it is replaced by 0.7 volts. Have you understood this? Our dynamic resistances will be given to you. So will be mentioned in the problem itself. Then so it is replaced by the dynamic resistance. Right? So in the problem it is given that the diodes are ideal. That is the reason why we have replaced. If it is reverse biased but not in breakdown, then it is replaced by open circuit. So if it is a reverse biased but in undergoes breakdown, then it is replaced by VZ volts, battery of VZ volts. If it is forward biased, straight away we have replaced it with a short circuit. If you understand, if it is practical diode means definitely can be replaced by a 0.7 volts. I have already mentioned that if Zener diode under forward bias conditions acts as normal diode, it is practically observed that if the cut-in voltage is that means the breakdown or the cut-in voltage is observed is 0.7 volts. Have you understood this? That is the reason why it is certified as acts as normal diode. Right? So yes, thank you. And let us see the next problem. In the circuit shown, cut-in voltage is 0.7 volts. Right? And Zener diode has breakdown voltage 10 volts. The breakdown occurs at 10 volts. Plot the transfer characteristics. The cut-in voltage of diode is 0.7 volts as well as Zener diode also. This is practical diode. Have you understood this? Right? So that means what does it mean? So the 0.7 volts must be placed in series with the diode. Right? So the equivalent circuit for this is, you can write like this. So this is the input voltage or series resistance. .7 volts is placed in series with the Zener diode. Similarly, so diode is also practical diode, and hence this is 5 volts, and 0.7 volts is placed in series with the diode because it is practical diode. Have you understood this? Right? So now let us see the different conditions. If VA is less than minus 0.7 volts, first case, this one, this is minus 0.7 volts. If VA is less than minus 0.7 volts, then what happens? Zener diode becomes a forward bias, can be replaced by short circuit. Right? So minus 0.7 volts will be here. And now the normal diode is off, can be replaced by open circuit. That means the first case is if Vi is less than minus 0.7 volts, then Zener diode is on, can be replaced by short circuit, and normal diode is off, can be replaced by, that means acts as open circuit. We understood this, right? So now the equivalent circuit corresponding to this condition is this is Vi R, and now Zener diode acts as short circuit, minus 0.7 volts. Now normal diode is replaced with a open circuit, 5.7 volts. Now the output voltage is minus 0.7 volts. In this case, if Vi is less than minus 0.7 volts, then so the output voltage is minus 0.7 volts. Have you understood this? Right? So Zener diode is forward biased, can be replaced by short circuit, and normal diode is off, so can be replaced by open circuit. Now the output voltage applied across the output terminals is minus 0.7 volts. And the second case is if if minus 0.7 volts is less than Vi is less than 5.7 volts. That is right. So minus 0.7, that means the first case what we have taken, less than Vi is less than, but before 0.7 minus 0.7 volts we have taken. Next case is if Vi minus 0.7 volts is less than, Vi is less than 5.7 volts. In this case, what happens? Can you guess? Right? So both the diodes are reverse biased, acts as open circuit. So that means this is reverse biased anyway, and so less than 5.7 volts is connected to the anode terminal, and hence so this is also reverse biased. Right? So both the diodes are reverse biased, acts as open circuit. In this case, both the diodes are equivalent to open circuit. Right? So under these circumstances, in this case, output is same as input. That means the output follows the input variations in this case. Have you understood this? And the third case is if the input voltage exceeds greater than 5.7 volts. Then what happens? You please tell me. So if the input voltage is greater than 5.7 volts, then so now the normal diode is in a conduction. Now the normal diode is in conduction. Immediately, so it acts as short circuit, so which conducts current. Have you understood this? This conduction, normal diode in conduction forces output to remain in 5.7 volts. Right? So normal diode is in conduction. Normal diode is in conduction. So once normal diode conducts, so this forces output to remain in a 5.7 volts. And so what is the breakdown voltage of Zener diode? Zener diode breakdown voltage is 10 volts. That means this 5.7 volts is not sufficient to cause the breakdown of Zener diode. Have you understood this, right? So Zener diode is reverse bias, but so it will not enter into the breakdown region. That means, so why? Because the normal diode in conduction forces output to remains at 5.7 volts only. This causes to prevent the breakdown of Zener diode. Breakdown of Zener diode, even if the input voltage increases to 100 volts or beyond that also, but still it will never enter into the breakdown region. And hence output remains at a 5.7 volts only. Why? Because the normal diode prevents the to cause the breakdown of the Zener diode. Why? Because it enters into the conduction state before the breakdown, Zener diode enters into the breakdown region. That is the reason. Have you understood this? Right? So this prevents normal. I will write down here. This is very important point. Normal diode prevents to cause the breakdown of Zener diode. Therefore, output voltage is 5.7 volts only, even if the input voltage exceeds 10 volts. It will never enter into the breakdown region. Have you understood this? This is one of the very interesting problem. Just please go through it. So two cases we have taken into account. One is if VA is less than minus 0.7 volts, then Zener diode is a forward bias, acts as a short circuit. Right? So 0.7 volts already we have replaced here. Right? So and hence Zener diode can be replaced with short circuit. And so now normal diode is reverse biased, can be replaced by open circuit. Now the output voltage in this case is 0.7 volts, minus 0.7 volts. And the second case is if VA is less than minus 0.7 volts is less than VA is less than 5.7 volts. 5.7 volts. Then both the diodes are reverse bias, acts as open circuit. Now the output follows the input variations. And the third case is if VA is greater than 5.7 volts, then normal diode immediately will be coming into existence. Why? Because the voltage connected to the anode, which is more than the voltage connected to the cathode. Now the diode is said to be forward biased. Immediately, that means the potential barrier will be eliminated completely. And hence the majority charge carriers can cross the junction, which constitute electric current. That is what is happening behind the screen. Have you understood this? Right? Now the normal diode is in conduction state. And hence will forces output to remain at 5.7 volts. This 5.7 volts is not at all sufficient to cause the breakdown of the Zener diode. Why? Because the Zener diode will enter into the breakdown if the input voltage exceeds 10 volts. At 10 volts, breakdown voltage or Zener voltage is 10 volts. That is why this is insufficient to cause the breakdown. But the normal diode will force the output to remain at a 5.7 volts only, even if the input exceeds 100 volts. Have you understood this? Right? So that is why the output is always 5.7 volts only, and Zener diode is in reverse bias but not in breakdown. Have you understood this? Right? So if you have any doubt, please comment. Please comment. Yeah, the current path, this can be addressed, this requires a little bit theoretical explanation, right? So if you go through our lectures, definitely you can understand, because some theoretical explanation is required to show the current paths and everything. Okay? So definitely we will extend our services to the possible extent. Muralidharan Naidu, yes. So let us see the next problem. In the circuit shown, Zener diode is ideal. That means, what does it mean? Again, a delta Vz, change in voltage, change in Zener voltage is assumed to be 0, and the dynamic resistance is assumed to be 0. That means, once it is forward biased, directly can be replaced by short circuit. And if it is reverse biased but not in breakdown, can be replaced by open circuit. If it is breakdown, can be replaced by a battery of Vz volts. Right? So, breakdown voltage of Zener diode is 6 volts. This is 6 volts. If the input is 12 volts, 12 sine omega naught, plot the output characteristics. Right? So, we'll see. If VA is positive, if VA is positive means, then what happens? So, positive is connected to the cathode. Now, the diode is, that means, let us assume that if VA is negative, if VA is negative means, now the Zener diode is acts as a, that means Zener diode is forward bias, acts as short circuit, can be replaced by short circuit. Let VA is negative. In this case, the Zener diode can be replaced by short circuit. Right? So that means a short circuit means, in the series circuit, short circuit means no voltage drop across the series terminal. And hence, the output voltage is same as input voltage, irrespective of, independent of R. That means irrespective of the value of resistance. Whatever the value of resistance may be. Follow? So if it is short circuit means, the same input voltage will be applied across the output terminal. So output voltage is same as input. That means during negative half cycle, the output follows the input variations. The output follows the input variations. That is, the conclusion can be drawn from this. And the second case is, if let VA be positive. VA be positive means, now the Zener diode is reverse biased. Under reverse biased conditions, we have to observe two cases. One is before breakdown. That means VA is less than 6 volts. And the second case is after breakdown. VA is greater than 6 volts. These two cases must be observed. Right? So the first case is Zener diode is reverse biased. Right? So the first case is if VA is less than 6 volts. Follow. Even if the Zener diode is reverse biased, but cannot undergo breakdown. Cannot undergo breakdown. Undergo breakdown. That means now it acts as, Zener diode acts as open circuit. Open circuit. In this case, so the equivalent circuit for this corresponding to this case is VA, and here the Zener diode is replaced by open circuit, and R, and whatever the input voltage will be applied across the open circuit terminals only, and the output voltage is 0. No voltage will be applied across the output terminals. Open circuit. Whatever the voltage, input voltage, will be applied across the open series branch only. Right? So then, so the output voltage corresponding to this case is 0. And the next case is if VA is greater than 6 volts. If VA is greater than 6 volts, now the Zener diode undergoes breakdown. Zener diode undergoes breakdown. Now it acts as a battery of Vz volts. acts as battery of 6 volts. VZ means 6 volts. 6 volts, right? So the equivalent circuit corresponding to this case is VA and a battery of 6 volts or V0. Just by applying KVL, just apply KVL by KVL. What you will get? VA minus 6 minus V0 is equal to 0. VA minus 6 minus V0 is equal to 0. Have you understood this? That implies the output voltage is VA minus 6. VA minus 6 volts. You can see. Right? So with this equation, mathematical expression, you can draw the input-output characteristics as well as transfer characteristics corresponding to this problem. Right? So the input-output waveforms. It says 12 volts is clipped off at 6 volts. Positive cycle, and during negative half cycle, the output is same as input. That already we have seen here. That case we have seen. If VA is negative, the output follows the input variations. Have you understood this? So that no problem. And during positive half cycle only, so the signal that lies above 6 volts is clipped off. Above 6 volts is clipped off. It means here VA minus 6. This is 6 volts. Like this. And similarly, like this. This is the output waveform corresponding to this problem. VA minus 6 V0. Means this is 12 volts. Input voltage, peak voltage is 12 volts. And output voltage is VA minus 6. That means 6 volts is clipped off. And 6 volts will be applied across the output terminals. Have you understood this, right? So the transfer characteristics corresponding to this problem is, we will draw here, transfer characteristics. VO and VI. So during negative half cycle, the output follows the input variations. That means VO is same as VA. And during positive half cycle, till 6 volts, the output is 0. Have you understood this? Till 6 volts, the output is 0. And after 6 volts, if VA is greater than 6 volts, then the output voltage is VA minus 6. VA minus 6. Have you understood this? This is transfer characteristics of the given problem. Transfer characteristics. Have you understood this? Just observe. You can see, you can verify here. So during negative half cycle, so output follows the input variations. That's what we have done here. So this is output follows the input variations. That is why. So just linear curve will be coming into the picture. And if VA is less than 6 volts, then output is 0 volts. Output is 0. And if VA is greater than 6 volts, now the Zener diode undergoes breakdown, acts as battery of 6 volts just by applying KVL. So we will get this equation, VA minus 6 minus V0. V0 is equal to VA minus 6 volts. So the corresponding input-output waveforms and the transfer characteristics corresponding to this is during negative half cycle, output follows the input variations, And before, if VA is less than 6 volts, the output is 0. If VA is greater than 6 volts, then output is VA minus 6 volts. This one, VA minus 6 volts. Have you understood this? Are you able to follow my lecture? Right? So please comment. Please comment. Oh, sorry, Ganesh. Good. So, if you have any doubt, please comment on this. Okay. Okay. Thank you, guys. So we will continue the same discussion tomorrow. So please attend the session. So if you have any doubt, so please send me through the mention in the comment box, so that we will try to the possible extent. We will try to clarify your doubts. Thank you. Thank you very much.